Born Accessible, Designing Graphic Content for Inclusive Experiences. Speakers: John Gardner, founder of View Plus; Julia Winter, founder and CEO of Alchemy; Arvind Satyanarayan, Associate Professor of Computer Science, MIT. Moderator: Roberto Manducci, Professor of Computer Science and Engineering, UC Santa Cruz.
Thank you, Karen and Ross. This is Roberto Manducci speaking from the University of California, Santa Cruz. I'm a professor of computer science and engineering here, and I'm also on the board of directors of Vista Center. Vista is hosting SciTech Global, this fantastic conference that I've had the honor to participate in since it started in 2020. And today, here for our panel on Born Accessible, Designing Graphic Content for Inclusive Experiences, I have with me Arvind Satyanarayan from MIT, Julia Winter from Alchemy, and John Gardner for View Plus. And I would like to start by asking my guest to introduce herself and tell us a little bit about their background. Let's start with Arvind. Arvind, please go ahead.
Thanks, Roberto. Hi, everyone. I'm Arvind Satyanarayan. I am a professor of computer science at MIT, where I lead a research group that studies visualization as part of the Computer Science and Artificial Intelligence Lab, or CSAIL. And so in my research group, we study lots of different aspects of visualization, from building software tools to make interactive visualizations, apply visualizations to understand machine learning models, think about, misinformation and disinformation around visualizations. And of course, the reason that I'm here, how we make visualizations accessible to people with disabilities.
Excellent. Julia, tell us something about yourself.
Hi, I'm Julia Winter, CEO and founder of Alchemy, based outside of Detroit. And before that, I was a 20-year high school chemistry teacher. Started the company to build interactive learning tools for chemistry and other STEM subjects, and came across the really gnarly problem of making them directly accessible. So we wanted to do that. So I love the title Born Accessible, and I will say I have watched SciTech Global for the last 3 years, and my team does book clubs about, we will divide up the talks. And so I'm so honored to be part of this panel.
This is great. We are honored to have you in the panel. Now, last but not least, John.
Hi, I'm John Gardner. I'm blind. I lost my sight about 35 years ago, rather suddenly. And at the time, I was professor of physics at Oregon State University. And I found it was hard to continue doing my research because it required a lot of graphical analysis, and graphics were not accessible to blind people. They barely are today. I founded a spinoff company called View Plus about a little over 25 years ago, and it's grown into a major company. It makes tactile graphics embossers. It's the only company that makes tactile graphics embossers. In fact, we sell them all over the world, and they have software that goes with it that we'll probably run across later in this program. And I appreciate being here. I admire the work that SciTech Global has done, and I'm very happy to be on the panel. Thanks.
Excellent. And I'm sure that many of our listeners are very familiar with View Plus and this product.
I would hope so.
Oh, well, my first question in this panel is to John, in fact. So John, when people make graphs or images or maps, the current way to make them accessible works in this way. A sighted person creates their image, a graphs, a map, and then when they remember, they will add some alt text, which is some text that describes what is in there. What could go wrong? Well, here is the thing. Lots of things, of course, could go wrong. How can we go beyond this paradigm? Sighted person adding at their will some alt text, if they remember. And how can you create documents that are natively accessible documents that can be consumed in more ways than just visually from the beginning. What do you think?
Well, we're trying to solve that problem. We being a group called Inclusio, which is funded in a large way by the National Science Foundation. View Plus is the commercial lead of that project. And that is precisely our goal, is to be able to make mainstream graphics that are automatically accessible. And we can talk later about how that is done, but I think it is certainly possible. And we're hoping to make it easy to simply make sure that when something is published as a graph, it will be accessible. So,
well, you made us curious, John. Tell us something more. How do you do this magic?
well, we put some meta software into a file. At the present time, the file format is pretty much has to be scalable vector graphics, SVG, but there are other formats that will probably come along in the future that we'll work on. And what this does is makes it, what's the word, interoperable among technologies. I mean, for example, my favorite way of reading graphics is by audio visual, where you have a tactile copy, nice tactile copy, of course, made on one of our embossers, and you touch it and it tells you what it is. For example, I cannot imagine a verbal description of the United States that really tells me what the map of the United States looks like. But as soon as I have a tactile copy, I can feel it. But I'm not very good, and most blind people are not very good at reading tactile graphics. So the tactile graphic talks. And if I put my finger on California, it should say California. If I put it on Oregon, it should say Oregon. Et cetera, et cetera. And there can be other information. And in fact, you could put a whole book into a graphic. That's called audio tactile graphics. One of the collaborators in this group is a small company called Vital that makes a haptic, audio haptic access in which you feel something and the screen vibrates. So you could feel this map of the United States, and as you cross a line, it would vibrate so that you know you're going across a state line. And it also, if you tap on it, will speak the name of the state, etc. And a third way is to simply make a freestanding tactile graphic in which there is text. The text is Braille. Braille labels are usually too big to put onto a tactile graphic. So what you do is you put small mnemonics of 1 or 2 Braille characters, and then you make a book telling what the labels that go with those are, which is a clumsy way to read something, but it works. And the present time, we're less than a year into this project, phase 2 project. We have it working for all 3 of those methods. So we can make a scalable vector graphic, and I can choose which of those 3 I want to use, push a button, I get a Braille copy, or I get a tactile copy intended for audio tactile, et cetera, et cetera. Now this is a mainstream, can be a mainstream SVG, published in a professional journal. And there's no reason that I can't just look at that and extract any one of these 3 methods. And those are only the first 3. Other methods will be coming along quite rapidly. It's intended to be very easily expandable. There's a couple of new multi-line graphics tablets that are on the market. They're not cheap, but they do work. And it's fairly straightforward to extend this so that that's the 4th. And then there is a 5th. And there are many ways that you can consume this. That's what I would call accessible.
Beautiful. And I would call it actually born accessible. So you have all of these different ways to access the data already in the document. Beautiful. Arvin, you also have worked on creating documents, so to say, that can be consumed in multiple ways. Tell us something about it.
Yeah, absolutely. So one of the things that I really liked about what, all the different options that John was describing is, not only do you have those different modalities available to you, right? Tactile, sound, verbalized speech, haptics, and things like that, but that you're using those modalities to get different kinds of information, right? That might be information at different levels of detail, information at different levels of resolution, or even totally different information whatsoever. And so that's a lot of the research that my group has been focused on. We sort of call it multimodal data representations, rather than just data visualizations, if you will. And a lot of this work has been led by my PhD student, Jonathan Zhang, who will soon be a faculty member at CU Boulder. And in particular, one of the things that we found is, as we've explored tactile sonified data representations, right, which is using a tone to sort of depict, time series data or something like that. So higher pitches indicate, higher data values, lower pitches indicate lower data values. And then, verbalized or textual representations is that there can be a lot of value in combining them together, right? So hearing just a sound play out is a really nice way of getting like a very high level overview of trends or things like that, right? We can pick out very easily if something suddenly spikes because it goes from like, a relatively flat tone to like a sudden high pitch or a sudden trough or something like that. With text, I get, really, really fine-grained information, right? I can get very precise values read back to me and things like that. And with tactile, I'm much more in control of when I'm receiving what kinds of data, right? Because I'm able to sort of move my hands around and feel the various tactile symbols. And so in that way, a lot of our research is figuring out, when do we care about which modality? And how do we use those different modalities to surface what kinds of information and things like that?
Beautiful. So multimodal, and with an idea that different modalities serve kind of like different purposes, and they can be used and interacted with in different ways. Fantastic. Exactly. Okay, very nice, very nice. These are all very promising, beautiful projects I'm hearing. Let me now direct towards education, because of course we're talking about graphic content. Let me think a little bit about STEM students, right? Science, technology, engineering, mathematics. And it is very difficult to teach STEM or to learn STEM just based on text, right? We need figures, we need graphs, we need diagrams, we need explanation. We need to somehow learn the spatial relationship of things, of atoms in the molecules, for example. Well, that's how I'm immediately thinking about Julia. So Julia, we need students to learn shapes and spatial relations. And clearly, if a student is has low vision or is blind, just adding alt text is not going to cut it. It's not going to work. So tell us something, some possible creative solutions, some of which you have been working on, to let the students access and manipulate shapes and to learn spatial relations.
Yeah, so this has been ongoing projects funded by Department of Ed, NIH, NSF, and NIDLR through SBIR programs. And we started with manipulatives that I used in my class, in my high school class. Like I would put atoms on the board, and I never taught a low vision student in my school. But I said, why could we do something with these manipulatives for Lewis structures is one of those things that people think of in chemistry. And could we use computer vision to recognize the pieces and then give guidance and feedback as the students learn? So that was our very first idea. in 2020, which got funded by the Department of Education. We had no idea how to do. We had zero knowledge. So we figured out how to do it and got a phase 2 grant from the Department of Education. And as we built these manipulatives, we 3D printed them, we designed them, we tested them with blind students and their teachers of visually impaired TVIs, and we added Braille, and we did research studies. And then when we were working with the teachers of visually impaired, they said, this is great, chemistry is wonderful, but you have to get something earlier. You have to get it into first, second, third grade because we lose our kids way before chemistry. So we started working with the same idea with common manipulatives in math, and we added textures to those common manipulatives to indicate color. So when the system would say, pick up the brown rod, the blind students would know what brown felt like. And so every student can use the tools. It's all designed to be born accessible, but also inclusive. So these tools are designed to be used in classrooms, in mainstream classrooms, but also to support the spatial relationship building that has to go on for the blind students to move into STEM, because spatial relationships are key to success in STEM. So we have that, and then we have a digital component, purely digital component, which generates dynamic alt text as the students use our keyboard accessible control panel in our software. So we are building for organic chemistry right now, general chemistry, and then hopefully our NIH phase 2 will come through and we'll have K-8 math over the next 2 years.
Very nice. And I hear things like manipulative and tactile, which is important, right? Because by acting on things moving together. And I must say, this reminds me some of the work of the Professor Arthur Kashmer. Some of the people in the audience might have known him. I'm sure that John remembers him. He passed several years ago, but he also was a big proponent of manipulative ways to learn, for example, mathematics, to put together little formulas with pieces of wood and etc. So I really appreciate that you're working on that. Arvind.
Can I add something? So one thing I really liked in what Julia was describing was the notion of dynamic alt text, right? I think one of the reasons that alt text maybe gets a bad rap is because so far we've treated text as a very static medium, right? It is essentially when the person who, usually the sighted person, designs the graphic, you hope they remember to provide the alt text, and then the alt text lives forever with that graphic, right? And the alt text can only say the one thing. And what I really like about what Julia is describing is the fact that that alt text can, change over time, right? Based on the ways that, in Julia's case, I think it's STEM students, right, are interacting and manipulating the manipulatives. And I think that, again, from a research perspective, one of the things that gets me really excited is that this feels like a really fertile sort of like design space, particularly right now with, generative AI and large language models, not just to be like, well, let's throw Gen AI at this problem because that's the hot, cool thing right now, but because many of those models are about manipulating text, right, and making text this much more dynamic medium. So one example from our own research, for instance, again, sort of shifting back to visualizations just for a second, is that it's very common, to see best practices for alt text around visualization to say something like, this is a line chart with, dates along the x-axis and price along the y-axis, and, maybe summarize what the trend is. And I think that's a reasonable first place to start, right? But boy, is that a very frustrating piece of alt text because it tells you like one thing, right? And one thing at not in a very rich way, versus for sighted people, when we're reading charts, there's lots of things that we're reading into it, right? We're reading context, we're bringing our own sort of like domain information and things like that. And so one of the things my students and I have been exploring is how we might use a large language model to bring some of that contextual information into a piece of dynamic alt text. So for instance, imagine that you have, a line chart of, the price of some commodity over time. And, you have essentially the large language model split the alt text into different segments to say, for instance, like, between 2008 to 2010, it was the Great Recession, right? And the prices of these commodities really fell down as a result. And then, in 2020, again, due to the COVID pandemic, right, the prices experienced a rapid decline. And so that's the sort of way that I think some of these more modern technologies can help us bring these more sort of like contextual domain-specific pieces of information and alleviate the burden on sort of the graphic designers and authors to have to remember, first of all, to write the alt text and then to convey all of this sort of rich metadata and cram it all into just a single piece of alt text.
I will say one of the things that our users, our screen reader users who tested our technology really liked was once they learned how the alt text would be describing what they were using on the screen, it was always the same. So one of the big problems with alt text is the standardization problem, because everybody authors alt text. There are best practices, but they're all different. And the other really interesting problem that we have looked at as an assessment company, so our tools assess student learning, the alt text can't give it away. So you have to actually build in the learning design into the dynamic alt text. So if you have a learning objective that wants the student to come up with X, you can't tell them what X is. So it's similar to, I look at some of your work, Arvind, and you want, like if a student was reading a graph or a piece of data, you want them to be able to synthesize that and not just be told what the trends are.
Exactly.
And that is one of the really tough problems in education space, because we want to build the scaffolds to allow the students to use critical thinking via alternatives to visualizations, which it is a design problem and really interesting to do.
Beautiful, very, very interesting. And I like this concept on alt text not necessarily being just a piece of static thing, because any graphical content can be described in so many ways, right? And so, perfect, beautiful. Well, this kind of leads me to my third main question for discussion, this to Arvind. So, all right, again, back to the paradigm. A cited designer created a graph, and then as an afterthought, perhaps, adding some, making accessible, right? So in this paradigm, blind or visually impaired individuals really are passive consumers. Here I'm standing here, hoping that this guy remembered to add something so I can understand and read what this figure is about, because there's a lot of reference to this figure in this article, but I have no idea what that is. So is it possible to turn this paradigm around and empower, I like this strong word, right? Empower blind and visually impaired individuals to create their own graphical material in a way that, of course, because they must make it accessible, is it natively accessible? Is it a pipe dream? Is it possible? Can we someday reach that? What do you think?
I think this is a really important question around empowerment, right? Because I think the issue is not just the one that you were describing, Roberto, where maybe the cited designer forgets to include alt text, but even in the ideal case, right? Imagine the cited author was to provide the alt text. Well, our blind or low vision reader, like all they can do is accept or reject whatever the alt text says, right? So that's not particularly empowering, at least not as empowering in terms of being equitable to the sorts of reading experiences that sighted people have, right? If I read a chart, I can accept what the journalist is saying with the chart, or I can read my own meaning into the chart, right? And so that's definitely a big thread of research in my group. But sort of looking at the last portion of that question you were asking, as I mentioned, my student Jonathan Zhang, who's been leading this work, he recently developed a system called Umwelt, UMWELT. And what Umwelt is trying to do is, rather than start with the assumption that there exists a, visual representation that we want to make accessible to people who are blind or low vision, Umwelt essentially is a screen reader accessible tool that is designed for screen reader users to use directly to author their own data representations, right? So we break that assumption that there exists a graphic representation that ought to be made accessible, and instead, kind of like the title of this panel, what are the data representations that screen reader users sort of can make that are born accessible by default? And so what Umwelt gives people access to is, all the modalities we've been talking about so far. So sound, text, and I hope to chat with John after this panel because we've just added some new functionality, or we will be soon, around tactile graphics. And the goal is through a fairly simple, drop-down style interface, people can, map different fields in their data set to, these different modalities. So you can say, I want to show price as pitch. I want the text to include, descriptions of, these other data fields and so forth. And then sort of like the operations Julia was talking about with the manipulatives, you can move between these different modalities. So I could play the sonification, hear that sudden spike in the pitch, pause it, switch to the textual representation and figure out like what's the precise data value, on what date did that occur and things like that, right? And that's a born accessible, if you will, representation because there never existed a visualization first, right? It didn't require a sighted person to create a visualization first and then make accessible.
It's
Wow.
beautiful. And John, this kind of like brings us back to your big inclusive project. Sounds something similar, right? We're at the point where we don't start with the priority of the visual representation of whatever it is they want to represent, but we just offer a multiplicity of ways to use it.
Well, yes and no. I will admit that my vision is more aligned with having a visual representation that is made accessible, probably because I was a sighted scientist for so many years and wrote so many papers, and now thinking about the graphs that I made for them, gosh, I should have done a lot better than what I published. My graphics were very dense and full of information and full of too much information, actually. But there are certainly ways that a blind person can make information that is simultaneously visually accessible and accessible in various other ways. And in a sense, that's sort of what I have taken on as a challenge, because we're really trying to make things that work for everybody. And I would like to mention, Arvin talked about using tone as a way to measure value. The very first product that View Plus put on the market back in year 2000 was an audio graphing calculator that did exactly that. It played a graph by tones, and the graph went up, the frequency went up. But it wasn't just the tone. You could stop it and have it give you the data points. It could do things like play to a minimum and speak the data at the minimum. It was quite flexible. It turns out that in testing this, we just didn't have enough blind people to test it on. So we tested it on several large classes at Oregon State. And we found, quite surprisingly, it took very little training for somebody to be able to use a tone graph and to basically use it perfectly, to know exactly what that graph looked like.
Yeah.
Another tone use that I'm very pleased with are GIS images. You have a map, you have, like the population of states, counties, whatever. Those are usually, if they're well made, they're in a color, and the color gets brighter and lighter and darker depending on the intensity on the population. So again, back to the map of the United States, California is the most populous state, so it would have a very bright color. Wyoming would have a dull color. And in tactile graphics, you can do that by making the size of the dots. So California has big, tall dots, and Wyoming has little small dots. But then if you can run your finger across it and hear the tone playing, man, that's what I call really good access. So, and that exists already. We've been doing that for years. So,
absolutely. Well, this was great. I think we had a fantastic discussion. I want to thank again my guest, Arvind Satyanarayan from MIT, Julia Winter for Alchemy, John Gardner from View Plus. This was the Born Accessible, Designing Graphic Content for Inclusive Experiences. This is the host, Roberta Manducchi, and back to Care and to Vista Center for SciTech Global. Thank you, everyone.
Thank you.
Thank you.